Welcome to lecture for research methods. This time we'll be talking about descriptive and correlational studies. So what's involved in these studies? Well, for descriptive research, obviously you're looking to describe something, and in psychological research we're talking generally about behavior, right? So you're looking to describe behavior. So to be able to describe behavior, you've got to measure it, right? And what makes it research and not just watching people is the fact that you do systematic measurement of behavior, right? It's not just, yeah, I went to the mall, I watched some people, I learned some stuff. Great, good research. No, it's making systematic observations where you're looking for something, usually. So you're going to the mall to observe how many teenagers have pants that need to be pulled up, right? Versus how many adults have pants that need to be pulled up. Maybe you look at something like that. But you're going with some purpose in mind, and you're recording things systematically, not just whatever occurs to you, but you're recurring. You've got some rules about what behaviors are going to be measured. If it's observation, if you're doing a survey, there's lots of different ways to conduct descriptive research. But again, it's all about measuring behavior to get some description. And then you don't just amass data and do nothing with it. You then summarize the data, right? And typically you do this in numerical format. Not always. Sometimes in kind of qualitative research, you may have kind of this qualitative description of a set of observations. The general theme was blah, blah, blah. But in quantitative research, which is more often used in our field, you're summarizing the data with numerical data, the average amount of time that something happens, the number of people that did something, right? And so again, you're just describing behavior. That's all you're doing. You're not manipulating anything. You're not looking at relationships. You're not looking at predicting. Just measuring and summarizing. Correlation research goes a step beyond that, so it still involves measuring behavior. But now the next thing you do, you measure more than one behavior, more than one variable, right? And you calculate the degree of systematic covariation among measurements. Or you calculate correlations. You calculate relationships. You look and say, okay, if values in one thing change, what happens to values of the other variable? So, if I look at, I got 10 people in a room, all different heights. As I go from the shortest person to the tallest person, what happens to the size of their pants? Right? It gets bigger. They co-vary together. A silly thing, but you get the idea. As we go from one value to another, what happens to the other? Usually for the same person or the same situation, right? When do you use descriptive and correlation research? Well, one reason would be to identify the limits of a phenomenon. Especially if it's kind of a new thing that you're interested in, people don't know much about it. Before you start manipulating things, doing kind of experiments, or even maybe looking at correlations, you just want to find out, well, how much is this happening? How much of it is there? Who does this thing? Right? So if maybe people have proposed that there's some sort of a new category of mental disorder that hasn't been the DSM yet, like a binge eating disorder, where people they binge eat large amounts of food, but then they don't purge. They feel guilty about it, and they feel bad about eating, and when they are eating a whole lot, they feel a sense of loss of control. Right? And there seems to be this group of people that do that, but it's not in the DSM yet. And so if maybe you think, well, I think there's this thing, this binge eating disorder, you want to go find out. And the first thing you do to find out is, how many people are there that do that? How much do they do that? How much do they eat? Whenever they're eating, what do they feel like? Excuse me. After they've eaten a large amount, what's their next meal like? Right? And so you're just collecting data to try to understand this phenomenon. What is it about? Before I look at what causes it, what can be done to change it, or what's the next step for people who have this. Right? Before I find that, I just want to know what's this thing about, right? And that's kind of where descriptive research comes in. And then correlation research can do a lot of that, but it also serves as the basis for prediction, right? If you know the relationship between two variables, even if you don't know anything about cause and effect, but you know that the two things are related, such that, well, if I know there's a high value of this, like if I know that your speed is 90 miles per hour, so you're traveling at a high rate of speed, I know that speed of driving and likelihood of getting a ticket are correlated. Right? I can say, well, if you're driving 90, I can predict you're very likely to get a speeding ticket. Right? So it's helpful for prediction, right? And prediction is huge in our field. Like, we want to predict all kinds of things, like when people, excuse me, have after some experience, say after prison or jail, what's the likelihood that they're going to reoffend? Right? We want to be able to predict that. If somebody has a gastric bypass surgery, right, the thing when they put the band around your stomach, what's the likelihood that this person is going to be able to eat small amounts and successfully lose weight, versus what's the likelihood that they're going to still overeat and rupture their stomach and kill themselves, right? You need to be able to predict behavior, right? And correlation research is often helpful to begin to make those predictions. So incredibly valuable, but we also always have to keep in the back of our mind that we can't use these things to examine cause-effect relationships. And that's more or less true. We can look at cause-effect relationships, but we can't, so if we say, okay, well, I think speeding causes you to get a ticket, let's see if there's a correlation, right? So we can look at a cause-effect relationship, but if we look at it with a correlation, and we find a correlation, that doesn't mean there is a cause and effect. It's evidence that maybe there is, because if there's no correlation, you probably don't have a cause and effect, right? If there's no relationship, then it's hard to say that there's a cause and effect relationship. Right? So a correlation is kind of a minimum requirement for a cause-effect relationship, but it's not sufficient. Right? And we'll talk more about that in a minute. But because a cause-effect relationship requires there to be a relationship at all, correlation research is often useful as a precursor to experimental research, right? So you go through, maybe you've trying to figure out what causes something to happen, what causes people to be depressed, what causes people to be less depressed in therapy, right? And when you do experiments, as we've learned, whenever you have an independent variable, you have to have a whole bunch of people for each level of that independent variable. Right? And if you say, well, if you don't really know what causes people to get better in therapy, what is it about therapy? And so, well, it could be a therapist experience, could be a therapist gender, could be a therapist feelings about the client, could be the amount of words that the therapist says in a session. You got all these different variables. You think, if you try to look at all of those in an experiment, you have a big old experiment, right? Huge. Much easier to look at lots of variables in a correlational sense. So we just measure all these different things, and then you don't have to manipulate it. Right? And again, the more people you have of varying levels of experience, the more generalizable your data will be. But you only need one person who's been a therapist for 10.1 years, one who's been there for 9.5 years. You don't have to have people at every possible value, right? Because we're measuring things on a continuum, looking at covariation. Right? And so we can look at a bunch of variables and say, okay, which, if any of these, are correlated with this outcome? And once you find, okay, well, these 1, 2, 3, 4 seem to be correlated. These others, there's no relationship. When people were more experienced, less experienced, talked more, talked less, had no effect, or sorry, didn't have no effect, had no relationship to outcome. Okay, well, I'm not going to waste some time looking at an experiment. But then if I can cull all those variables down to just a couple, 2, 3, 4. Now I can go back and do an experiment and manipulate those variables, assign people to different levels, right? And then I can get a better idea of which, if any, have a causative relationship to the dependent variable. So often used as a precursor to experimental research. And then the biggest reason is descriptive and correlational research in particular are used whenever it's unethical or impractical to manipulate an independent variable, right? Sometimes we're really interested. Our question is a cause and effect question. We want to know what's the effect of this thing on this thing, but we can't manipulate the thing that is the independent variable, right? So what's the effect of losing a parent? You can't manipulate it. You can't kill people's parents. That's not right. What's the effect of having an affair on self-esteem? You can't manipulate people to have an affair or not have an affair, right? So it's unethical, impractical to manipulate those things. Even though maybe we think, right, our theory is that there's a causative relationship, but we can't do the experiment, so we take it from a correlational standpoint. And when you do that, you don't say, oh, well, all I can do is correlational. Crap, I'll never ever know. No, it just takes a lot more work, right? And we'll talk about what that work is at the end here when we talk about analyzing results. Okay. Where does the data come from? Potentially a lot of places. One source could be ex post facto data. So when you've conducted a study for some other purpose, and you maybe have some questions on there, demographic stuff that you just included because you needed to report it in your sample, about your sample, whether this many people who were this old, this many people who were of this ethnicity, but you at the time you didn't think, oh, I really want to know the relationship between age and my DV, or between ethnicity and my DV, right? So it wasn't part of your design. But you gathered this data, and then after you finished and you maybe found something what you were looking for, or you didn't, whatever, you imagine, hey, I got this data here. Maybe I can find some other interesting stuff here. Let me look around. So you're looking at existing data that was gathered usually by you for some other purpose, and now you're going back to repurpose it. And the quality of the correlational descriptive data you get from that depends a lot on the quality of the data from the original study, right? And again, how well it suits your purpose. Because again, if you didn't gather the data in a way to answer your new question, it may not quite fit, right? Maybe if you're doing some study about attitudes and relationship between different attitudes, and you throw in there some question about previous experience related to things. So maybe it's attitudes about schooling, and you throw in there one question: did you go to public school or private school? Right? And all you just kind of want to know, because to look at, well, I wonder if there's I want to be able to tell how many people at public school, how many people at private school. But then you go back and say, well, I'm interested to know about the different types of private schools many people went to, different types of public schools, and I want to know if they were satisfied with their education. But you didn't ask that. Well, you can't go back and get more data from these old participants usually. So, again, the questions you're able to ask are limited by the existing data, right? Which is a similar problem that you get from archival data. And archival data, in many ways, is a lot like ex post facto data in that it's there, but it's usually not something from something that you did. It's again data that were collected for some other purpose, and often not collected for research. Right? So students' SAT scores and their college GPAs, those numbers are in databases, and they're not necessarily there for research. Arguably, some of that's there for institutional research whenever university schools want to know how they're doing, but they aren't collected for that purpose. They're collected to decide who gets into school, right, and then who gets to get out of school as far as the GPA. So collected for some other purpose, but it's there. Hey, it's free data, and you can do a lot of interesting stuff with archival data. And it comes in two general flavors: coded and uncoded, right? So sometimes the data won't be in a format that lends itself readily to analysis. It'll be uncoded. So maybe essays that are written by students applying to graduate school. So here's the essay. That's not that's uncoded data. Because you look at that and you go, okay, what do I do with this essay? But you can convert it to coded data. Right? And typically, you need to come up with some coding system to transform the data. Lots of different approaches to do that. One of the most common is content analysis, which is a very ground-up approach where you would probably start by reading some essays, right, and thinking, okay, well, it seems like this one, I see some themes emerging. And that just kind of intuitively you sense, okay, these seem to be about overcoming struggles. These seem to be about promoting accomplishments. These seem to be about future goals. These are the different themes I see. Right? But then you don't just stop there and you don't go, okay, I'm going to correlate these myself. This one is this is this. No, you develop themes, and then you get a team of grad students, usually. Unless you're a grad student, then you get a team of undergraduate students to help you go through, and you tell them what the themes they're going to be looking for are. You give them examples. Okay, this theme would sound something like this. And then you have them go through, and they read all the things, and they code them for the existence of those themes. And you can number the themes, letter the themes, theme 1, 2, 3, 4, A, B, C, whatever. And you can even make it even more quantitative, the degree to which this theme is present in this essay on a scale of 1 to 10. right? And you have them go and rate all the stuff, and then you can look and say, okay, do they agree with each other about what themes are present? You can look at inter-rater reliability, and then now you've got these numbers that you can look at and do kind of interesting things with to say, okay, well, the essays with certain themes seem to be associated with a greater likelihood of gaining admittance, right, or greater likelihood of being successful later on in graduate school. Right? But you can't do that until you transform that data and you code it. Excuse me. Observational data comes in, again, different types. Laboratory observation, where it's very controlled. You're bringing them in, you're putting some limits on the setting, which, again, takes away from external validity, but increases internal validity, to agree here. We have more control over what you're seeing, and that's sometimes helpful. You can also have naturalistic observation, where you just go out and observe whatever behavior you're looking for in its naturally existing environment. Big in animal research, but also in some human research, especially for social psychologists and sociologists. This is again where you would go to the mall to observe teenagers rather than bringing teenagers into the psych lab to have them interact with a Confederate or some kind of more artificial situation. We're going to see what they're doing out in the world, right? And or we could bring them in the lab and then tell them, okay, we have this social media program we want you to interact with this person on, right? That would be a laboratory observation versus hacking into their computer and observing their online interactions. That would be naturalistic. And then the third type would be participant observation. And this is where it's kind of this naturalistic, but you as the researcher are putting yourself in the environment too. You're not just standing back watching, you are participating and observing. So this is where maybe you're getting on Facebook and chatting with people, and while you're chatting with people, whatever they're saying back to you are data, right? Or if you're, and you do this sometimes whenever you have groups that are hard to get data on. Like if you wanted to know, what these knucklehead skinheads, they won't generally fill out surveys for you. But if you said, well, I really want to know what drives these people to do these things and act in these violent ways, one way to do that research is to shave your head and pretend to be one of them. Potentially dangerous, obviously, but you could go in and do that and observe them at the same time and gain access to observations you might not have access to otherwise. Obviously, problems with each of the types of observation. With participant observation, it's difficult, if not impossible, to separate and identify the effect that you have on what you're observing, right? So if you're going in and pretending to be a skinhead, how do you know that what they're doing, the way they're behaving, is the way they would behave if you weren't there? Right? Maybe they're reacting to something in you, and they think, oh, you want to hear this or you want to see this, right? And then with other types of observation, laboratory, and to some degree naturalistic, if you're not very unobtrusive, you have the potential for reactance, where again, just the fact that they're being observed, and if you're not doing participant observation, usually they know they're being observed. If you're doing participant observation, you're usually lying to them, so they don't know they're being observed. Otherwise, you bring them to the lab, they know they're being watched, and when people know they're being watched, they act differently, right? So, especially as the situation becomes more artificial and less realistic, your data may have questionable value. And beyond their reacting to being observed, there's also the potential problem of with observation of biased interpretation, right? That whenever you're observing stuff and people aren't writing down exactly, on a scale of 1 to how they feel, but they're making some face, and you're rating, okay, their smile on a scale of 1 to 10 shows that they were a 7 on happiness. Right? That's your interpretation of some stimuli, which is potentially subject to experimenter bias. And again, there are ways to reduce that by having people who make the observations not be aware of the hypothesis, right? But even if they aren't aware of the hypothesis, that kind of takes away the bias of trying to support the study. But their own personal biases will still be there and could potentially cloud the data. tests. So existing tests generally are just existing sets of questions. There are sets of questions that have been previously administered to enough people that somebody gathered some data regarding what the answers to the test questions mean. Right, so an IQ test, a personality test. These are things that somebody has given to a lot of people, so that now we can say, okay, well, if you answer this way, you're like 20% of people. You're like 50% of people. You know, you seem to be outgoing or introverted. And we can say that about you because we've researched this test on other people, right? We've found out how people performed in that test, and then we've measured some other behavior and looked at the correlation between the two. Right? So there's that existing data so that you can make sense out of what that test means, and not just people wrote down answers on a piece of paper. Well, that's not your finding. Your finding is they demonstrated high intelligence or low conscientiousness. Whatever you're looking at, there's some construct there. And if you have an existing test, there's some information out there about the degree to which that test measures the constructs you're interested in. Surveys are similar, but generally surveys are things that, and there are sets of questions that you create. So now you don't have that existing set of data saying, well, yeah, you are measuring the construct that you say you're measuring. So here, really, the quality of the data you generate depends on the quality of the questions. And after you've gathered data, there's some things you can do in terms of factor analysis, cluster analysis, where you can start to build some evidence that your survey questions did measure what you intended to measure. But it's harder to make that case than if you use some existing test that has established, psychometric properties. Okay, in terms of analyzing data from descriptive correlational research, with descriptive research, again, it's really about summarizing data. So measures of central tendency, the mean, median, and mode, so the average, the middle number, and the most frequent number. Remember that from stats, right? And you probably also want to talk about the variability, so standard deviation, right? Maybe even the range, so the highest or the lowest scores on some variable. Potentially, you might even do some comparison of means. And when you compare means for descriptive research, you're not saying that these two things are different, therefore there was an effect. You're just saying they were different. People ate more vanilla ice cream than chocolate ice cream, and the difference was big enough that it can't be explained just by random variability in ice cream preference. Right? So if you're going to do something like that, probably use something like a t-test, pretty straightforward. Sometimes you want to compare frequencies. So whenever you have kind of data that are not quantitative in terms of amount of something, but just number of people that did something, number of people that showed up to a party whenever you advertised that there would be free food versus the number of people that showed up whenever you advertised it'd be free booze. Right? Number of people, because you have a number, those aren't averages, and if they're not averages, you can't use t-tests. So you use something like a chi-square goodness of fit test. And then if you want to go beyond that and look at relationships between variables, obviously you're going to be using some sort of correlation. And the one we usually talk about is the Pearson correlation, which looks at the linear relationships between variables. But there are other correlations, that correlation coefficients and correlational tests that are out there for nonlinear relationships and for relationships between variables that aren't continuous in nature. Kind of your non-parametric tests. And you can also, again, if you have kind of frequency data, use a chi-square test of independence to look at the relationship between two variables that aren't continuous. It's basically thinking about correlation between two things that aren't measured on a continuum. So gender and what major people chose at university. Right? You can't calculate a correlation between those, excuse me, those two things, right? Because you have two values of gender, typically, and then some finite number of majors you're looking at, maybe 5, right? What's the correlation between gender, and major choice. That doesn't make sense. You can't calculate a Pearson correlation coefficient for that. But you can do a chi-square test of independence, where you look at the frequency of observations versus what you would expect if the two variables were unrelated. Right? It's basically looking at if the two variables were unrelated, you'd have equal number of men and women in all majors. And the chi-square says, okay, well, that's what you'd expect if there was no relationship. Given what we observed, how far apart are those two different models? Right? What else can I tell you? In terms of interpreting correlations, again, I said before we come back to this, we don't interpret cause and effect from correlation. Right? It's kind of the precursor, but it's not enough. And it's not enough for two main reasons: the directionality problem and the third variable problem. Right? If A and B are correlated, we don't know if A causes B or B causes A. Right? So we say that there's a correlation between amount of violent TV people watch and how violent they are. Okay, was watching violent TV make you violent? And the answer is yes. But aside from that, just looking at correlation, we don't know for sure. Or is it that people who are violent and enjoy being violent enjoy watching violent TV? Right? We don't know which way it goes. And then the third variable problem is the one where often talk about when we have kind of these nonsensical correlations, where well, not nonsensical, but nonsensical interpretations, where there's a correlation between the number of ashtrays in your home and the probability that you're going to have lung cancer. Does that mean ashtrays cause lung cancer? No. There's a third variable that explains the relationship between those other two variables, such that the number of ashtrays is related to the amount you smoke, and smoking is related to lung cancer, and smoking does cause lung cancer, right? So we cannot interpret causation from correlation. It's a clue, but it's not sufficient. Right? The other thing you have to look out for is the fact that correlations are so easy to calculate. You get I've got these 6 variables, and I'm going to throw them into a correlation matrix, and so you're correlating all 6 variables with each other, right? So A with B, C, D, and E, and F, and then B with C, D, E, and F, and C with A, B. You get my point. You're doing multiple comparisons. You're doing lots of statistical tests, multiple analyses. The more analyses you do, the more likely it is you're going to have a false positive. A false positive in terms of a type 1 error, right? Because you conduct the test and you put alpha at 0.05. You got at most a 5% chance of making a type 1 error, right? If you reject the null hypothesis. Right? Do that again, well, now you're likely to make a type 1 error just went up. Do it again, it's going up. And if you do it a bunch, as people often do with correlations, you do 20 correlations, you're going to have one of them come up positive, even if there's no relationship, just because that's how we've designed the statistics. Right? We've allowed this small chance of being wrong, but you do something a bunch with a small chance each time, that chance adds up overall. Right? So you got to be careful of that. You also want to not make too much of statistically significant correlation sometimes. Sometimes they will be statistically significant, but otherwise insignificant. And this happens if you have a really large sample size, right? If you have a huge sample size, because statistical significance is influenced by the effect size, so how much of a relationship is there, but it's also influenced by n, the sample size. So if you get a huge sample, you could have a correlation of 0.04 that's statistically significant, and that 0.04 accounts for what, 1.6% of the variance. That's nothing. It's meaningless. It doesn't add anything to your prediction or to your understanding of a phenomenon. So how big does a correlation need to be significant? Well, it depends on what you're talking about. And generally, if you're not an expert in the field, the only way to know is look at other research that's been published and what other kind of the level of correlations people have published in terms of the variable you're looking at. If you're trying to predict aggression, the relationship you found Are you able to predict aggression as well as some other variables? Or if you're way below their prediction levels, if the typical correlation for predicting aggression is 0.4 and yours is a 0.1, then it may not be that significant, that important. So we want to be careful about interpreting significant findings too liberally, but you gotta watch out for when you have non-significant or null findings. Going, crap, no relationship. My experiment sucked. There's no relationship. I was wrong. You may not have been wrong. Right? A couple reasons that things might be non-significant, but there might still be a relationship there, and you just didn't find it. Right? The biggest reason, insufficient power. Maybe your sample size wasn't big enough. Again, the bigger the sample size, the easier it is to detect an effect. So if you have too small a sample, or if you have too many variables, it's going to be hard to find an effect, because as your sample gets smaller and as your number of variables get larger, it eats up degrees of freedom, right? And again, makes it harder to find statistically significant findings. So you want to make sure that your your study is sufficiently powered. You might also have the problem of restricted range, and this is where one or more of the variables you're looking at, you didn't look at a wide enough variety of the variable. So if I'm looking at the correlation between patriotism and number of American flags you have in your home, if I go through that study on Fort Hood, I might find no relationship between those two variables. Well, people who are patriotic, it doesn't make any difference. It doesn't relate to the number of flags they have. Well, you might find that Fort Hood has a lot of really patriotic people, and you have this restricted range where you're just measuring the upper end, and maybe the same thing where they all have a whole lot of flags. And if you have that restricted range, there's no variability. If you have no variability, you can't have correlation, because correlation, again, is all about covariation, and you can't have covariation if you don't have variation. Right? So if everybody is very similar to each other, which again we often want in experiments, it's bad for correlation. So we want diversity, because you can only find relationships if you have diversity in your variables. So restricted range could be a problem. Could be head insensitive measures. So I'm measuring depression, and then rather than giving kind of an established test, I just looked at people. I made some judgment about their face on a scale of 1 to 10 how depressed I thought they were. I may not be able to pick somebody who's depressed, somebody who's not. I might say, oh, you're about a 6 and you're about a 5, but really they're far apart and very different. But my measure, the way I chose to measure that construct, wasn't sensitive enough to pick up the important differences that were there. Right? And again, that relates back to variability. Without sensitivity, it limits your variability. And then the last thing, you might be using the wrong type of correlation. If you have a non-linear relationship and you're using kind of a Pearson correlation and looking at it in a linear way, you'll find no relationship. Right? The relationship between anxiety and performance. And so at very low levels of anxiety, hey, this test come up, I'm not really worried about it. I'm not going to study. Be fine. You very well may do poorly. Right? If you never study at all because you have no anxiety. As anxiety starts to go up, I'm getting a little worried better. So the more performance starts to go up, I get more anxious. And there's this point where at very high anxiety, performance might start to come back down. Right? Where super anxious people get so anxious that they end up drawing a blank and doing very poorly. So there's this curvilinear relationship between anxiety and performance. Right? But if you run a Pearson R looking at differences in anxiety, differences in performance, you'll find a zero correlation, right? Because it basically is finding the best fit line. The best fit line in a curve is a flat line, and a flat line is a zero correlation. Right? So make sure. Simplest way to check on that is look at the scatter plot of the data. Look at the actual data points for all the responses, and see if you can see a trend in the data. We've been talking here mostly when we talk about correlation, especially about kind of thinking about two variables at a time. But one of the things you can do with correlation research is look at relationships among multiple variables, and that's really important because you can look at things like moderation. right? And moderation is whenever the relation between one variable, variable A and variable B, so there's some relationship there, but it differs depending on some other variable, right? Um, so for example, if you're looking to buy a car, maybe you're watching the prices online, and you're well, as the prices are coming down, the likelihood of you buying the car is going up. Right? So there's this kind of zero order correlation of as one goes down, one goes up. Pretty straightforward, right? But if you say, oh, that's true, okay, well then all we have to do to sell you a car is lower the price. And so we find a nice Yugo. We put it up at $10,000. Start lowering the price, and at some point you're going to buy the Yugo, right? It's like, well, no. That relationship is only true for certain cars, right? There's this other variable in there, probably in terms of which car I want, that moderates the relationship between a price drop and likelihood of buying. Right? And you can use things like regression to identify moderation. We won't go into the details right now, but basically you enter an interaction term, and if it's significant, you've got moderation. Excuse me. But since we brought up regression, the other thing you can do is, for correlation, instead of saying is A correlated with B, we can say, okay, we're trying to predict some outcome. We're trying to predict success in therapy. Right? We've got maybe 5 variables. And rather than doing 5 different correlations, each one of the variables correlated with outcome, throw them all at once with regression. That's what regression does. It does multiple correlations at one time. And they can fight it out and see which one is the best predictor. Whichever one accounts for the most variability in outcome emerges, and it tells you, okay, it accounted for this much variability. These others, after that one took its bite out of the variability pie, these others accounted for this much, and this much, which is a pretty helpful thing when trying to figure out what's the best predictor of something happening. Right? Regression will also be used for moderation, and we talk about moderation, we always have to bring up mediation to help sure you understand the difference between the two. And again, moderation is whenever the relation between 2 variables exists, but it exists differently at different levels of some third variable. Right? It depends on what level of that other variable you're looking at, what that relationship between A and B looks like. Mediation is a little different. Mediation is where it appears that there's a relationship between 2 variables. This is kind of your classic third variable problem, but that relationship isn't necessarily doesn't depend on the level of some other variable. But the fact is that it's better. The relationship is better understood as not the relationship between A and B, but that A influences C, and C influences B. Right? That's mediation, where the relation between A and B is mediated by C. So it's not that the relationship differs; it's that one affects the other. That's mediation. Okay, this kind of straight line. Whereas moderation is more, well, the relationship depends on what's happening here. Right? So as the price is going down, that doesn't affect what car you like. That's a separate variable. It's not affected by one or the other. Right? What car you like isn't affected by what car you buy. Right? But the relationship between the price and what car you buy is affected by what car you like. Versus mediation, excuse me, would be more like the ashtrays related to the cigarettes, related to the cancer. Right? So it explains why there's this apparent relationship between 2 other variables. Okay, that's all for now. Take care.